This is the key to worksheet 2.2, part 8. And on this worksheet, you're graphing piecewise functions. So in graphing piecewise functions, notice that in our case, we're going to have two parts of each function. And so f of x is equal to x minus 1 if the value of my domain is less than or equal to 4. And if I pick numbers greater than 4, like 4.05, 4.21, things like that, then I'm going to use this part of my function. Okay, and the same thing with the next problem. All right, so when graphing piecewise functions, you need to look at each part individually. So what I would do is I would say y equals, remember f of x, let's just write it as y, equals x minus 1. I'm going to graph this part when x is less than or equal to 4. Okay, so since this is linear, most of our items will be linear. But since this is linear, I just need 2 points. So I must use this value of x that I see, because that's where I'm going to start. I'm going to start at 4. I'm going to pick numbers less than or equal to 4 in my domain. So if x is 4, and remember, since that's an equal sign, when I plot that point, it's going to be a closed circle. So when x is 4, I get 4 minus 1, which is 3. All right, so there's one of my points. I'm going to go ahead and plot that point. So 4, 3 is here. All right, closed circle. Then I got to pick another value of x that's less than or equal to 4. Okay, so remember, that's the only time I can use this part of the function is if x is less than or equal to 4. So let's say x is 2. So if x is 2, I get 2 minus 1, which is 1. So I'm going to plot the point 2, 1. All right. Oops, sorry, right here. So 2, 1. All right, so notice those are closed circles. All right, because those points, the x value is in this domain. So when x is 4, see the x value here is 4, right? When x is 4, it's in my domain because it's equal to. When x is 2, in fact, any other number I use that's less than or equal to 4 will be in my domain. So these will all be closed circles. So if I do another point, let's say 0, 0 minus 1 is a negative 1, and I apply that point 0, negative 1, that's here, closed circle. All right, now, you got to remember, do not draw a line that goes like this with two arrows, all right, because you're not graphing this line, you're graphing that line for x values that less than or equal to 4. So if you do this, if you graph a line with two arrows, you're graphing the line when the domain's all real numbers, but that part of the function, the domain's not all real numbers. The domain is less than or equal to 4. All right, so that's why you always need to start here. And so therefore, you just put your pencil point here, connect the other points, and there's your ray. Okay, so it's not a line, it's a ray. All right, now the other one, so you have y equals negative 3, and then again, x is greater than 4 this time. You still must use this value. Some of you are starting at 5. You can't start at 5. Because if you start at 5, what about 4.1? What about 4.06? What about 4.0008? You're forgetting all of those numbers that are between 4 and 5. All those x values between 4 and 5. I'm not sure why you are starting at 5. Or because you keep wanting to use whole numbers like we do here, to use integers. But remember, you got to be careful. If you start at 5, you're forgetting that 4.1's in there, 4.27's in there, and so on. 4.6483's in there. All right, so you have an infinite number of x values between 4 and 5 that you're missing. So that's why you need to start here. So when x is 4, this says my y value is always equal to negative 3, so that's going to be negative 3. But remember, when I go and plot that point, I cannot use a closed circle here, because then that would no longer be a function. Because if I put a closed circle here, then that means when x is 4, there are two y values. But remember, the definition of function says that for each x coordinate, there's got to be only one y coordinate. So that's why when you look at your domain right here, one's an equal sign, one's not an equal sign. So this one's going to be open. So when x is 4 and y is negative 3, I'm going to have an open circle here. All right. And then I got to pick another number that's greater than 4. Let's say 6. So if x is 6, y is going to equal negative 3. In fact, remember from previous lessons and topics, y equals negative 3 means the y value is always equal to negative 3 no matter what x is. And so I'm going to put the point 6, negative 3, which is here. All right, and notice that's closed because x equals 6 is in this domain, so that's closed. X equals 4 is not in this domain, so that's why that's open. All right, now do not draw a line here, okay, because first of all, that would no longer be a function. It fails the vertical line test. Secondly, if you draw a line, you're saying that I'm graphing y equals negative 3 for all real numbers, and that's not true. You're only graphing this when x is greater than 4. So you get this ray. You get the horizontal ray right here. And there's your graph. Okay? All right, number 2. So again, same idea. Notice that I'm going to, my function is 4x plus 5 if my x values are less than negative 3. And my function is x plus 5 if x is greater than or equal to negative 3. Do this in pieces, just like I did here. That's how we did it in the lessons. So we get y equals 4x plus 5. And then, remember, the domain's not all real numbers here. The domain, this is linear. Remember, in the past, when we graph a linear function, you were asked to find the domain was all real numbers. But that's not the case when we do in these piecewise functions. Your domains are restricted now. So here, I can only use x values that are less than negative 3. So when I do my t-table, again, I have to use this. That should always be the first point you should list is this one, the first x value. But there's no equal sign, so when I actually graph it, it's going to be an open circle because x equal negative 3 is not in this domain, but I still must use it. Because if you say I'm going to use negative 4, you're forgetting all of those x values between negative 3 and negative 4, and there are an infinite number of those. So don't start at negative 4. You must start here because you're forgetting about negative 3.1, negative 3.6, negative 3.852, negative 3.0000999, so on. There are an infinite number of values between negative 3 and negative 4. So don't just jump to negative 4. You're forgetting all about these x values in here. But when x is negative 3, this says my y value is going to be 4 times negative 3 plus 5. 4 times negative 3 is negative 12. Negative 12 plus 5 is, what, negative 7? Okay. All right. And then let's go to negative 4. So when x is negative 4, I get 4 times negative 4 plus 5. 4 times negative 4 is negative 16. Negative 16 plus 5 is negative 11. Okay, so negative 11. All right, so I'm going to plot the point negative 3, negative 7, which is right here. Negative 3, 1, 2, 3, negative 7. Open circle. So notice there's an open circle here. And then I plot the point negative 4, negative 11. The negative 4, negative 11 is about here, closed circle. All right, and then I draw my ray, and there's my graph. Okay. Now the other one, y equals x plus 5 if x is greater than or equal to negative 3. So again, I must use negative 3. And notice that's going to be close because there's an equal sign. So x equal negative 3 is in this domain. X equal negative 3 is not in this domain. So that's why I had an open circle there. So I get negative 3 plus 5, which is 2. So I'm going to plot the point negative 3, 2. So negative 3, 2 is right here, closed circle. And I need one more since this is linear. So let's say x is 0. So when x is 0, I get 0 plus 5, which is 5. So 0, 5 is here. Okay, so then I graph that ray, and I get this. Okay, all right. So remember, these functions themselves, right here, if the domain was all real numbers, those would be lines. But since I'm restricting my domain, I'm going to get rays. And on these rays, the endpoint's either closed or open. Closed or open. Okay? Now, number 3. So notice that number 3, one of my functions is quadratic and the other one's linear. All right, so let's do the first one. So y equals x squared plus 1, and x is greater than or equal to 0. All right, so remember, if this right here, if the domain was all real numbers, you remember what that looks like. If the domain was all real numbers, then x squared plus 1, the vertex is 0, 1. And when x is 1, y would be 2. So remember symmetry, so then I get this point. When x is 2, y would be 5. And so I get this, right? The idea of symmetry, I'm using symmetry to do the other side. All right, so that would be that if the domain was all real numbers. Okay, but the domain's not all real numbers. The domain is, for this one, I'm only using x values that are greater than or equal to 0. But remember, since this is quadratic, I can't just use 2 points like I did the others. I may need about, see how I use 2 points here and 2 points here and 2 points here? I'm probably going to need about 3 to draw a curve, because remember this quadratic is more curved than, and these linear functions are straight lines, or in this case rays. All right, so I got to use 0. If x is 0, I get 0 squared is 0. 0 plus 1 is 1. So 0 squared plus 1, right? So I apply the 0.01. You can't see it, but that's about here. All right. If x is 2, let's do 1. If x is 1, I get 1 squared plus 1, which is 2. So 1, 2 is here. And notice I put a closed circle. This is closed because 0 is in this domain. See that equal sign? If x is 2, I get 2 squared plus 1, which is 5. So 2, 5 is right here. All right. And so notice that this graph then looks like this, like a parabola. See how it looks like this one? So it's actually this piece right here. Okay. Then the other part of the function is this one. So y equals x minus 3 if x is less than 0. I must still use 0. Don't jump to -1 because you're missing all those. If you jump to -1, you're missing all those x values that are between 0 and -1, and there are an infinite number of those. But when I graph that point where the x is 0, that's going to be open because 0 is not really in that domain. So when x is 0, I get 0 minus 3, which is -3. And when x is -1, I get -1 minus 3, which is -4. All right, so 0, -3 is right here, open circle. And then -1, -4, -1, -4 is right here. And then you get this ray that looks like this. And then finally, number 4, okay, notice that those are all constant functions. See, there's no variable attached to this, right? So it's kind of like what we did here. So you had that horizontal ray. So these are constant functions. So the first one says that y equals 4, and I'm restricting the domain to x less than or equal to 2. So I must use 2. You must use 2. Notice it's an equal sign, so 2 is in this domain. So when I graph, I'm going to put a closed circle for that point. But that says when x is 2, what's the y value? Well, the y value is always equal to what? 4. In fact, this is always going to be 4, right? No matter what x is. But remember, this is a line. In this case, it will be an array. So I need another point. So I got to pick something less than or equal to 2. So let's say 0. If x is 0, y is 4. So I put those points. 2, 4 is here, closed circle. 0, 4 is here, right? And so then I draw my ray, and I get this. And the next one, y equals -2, and this time x is greater than 2 for x greater than 2. So again, I must use 2, because if you jump to 3, if you go from 3, you're forgetting all about these x values between 2 and 3. 2.0006 is in here. All right, so you can't just start at 3. So when x is 2, my y value is always going to be negative 2, right? So no matter what my x value is, my y value is negative 2. No matter what my x value is, y is always equal to negative 2. But remember, though, when I plot the point 2, negative 2, that's going to be open because 2 is not in this domain. But I still must use it. Because if you start, see, if you start at 3, which some of you do, so if you start here, and some of you put an open circle, and you should know that's a closed circle. I'm not sure why you're putting an open circle there. Don't put an open circle here, because you're asking yourself, you're telling yourself this: if I put an open circle here, then that means that 3 is not in this domain, but it is. Isn't 3 greater than 2? So that should be closed, right? But then you're going to do this. This is what you do. But then you forget, well, what about the numbers that are between 2 and 3? I forgot all about those. So that's why you always need to start here. So when x is 2, my y value is negative 2, so that's open, and then I get this. Now don't forget that should really be. So I put a closed circle here. Don't think you have to have a closed circle there. That's just supposed to be. That was just part of our discussion. So I'm going to go ahead and take this off. But remember, it's going to be open all the way to infinity. All right. So let me just quickly remove that dot, because I don't want you to think that you have to have a dot there. So that kind of messed it up a little. But basically, you're going to go from 0. I'm sorry, from this open circle all the way to infinity. And I'll fix this in a little while. Okay. All right. So let's see if it'll work. All right. So it should be this. Okay. All right. So that's the key to the worksheet. 2.2 part 8.